Okay, example 2, we have an object that's executing simple harmonic motion. This is called to and fro oscillation on a smooth floor. There's no friction. You're oscillating about the center point. The center point is here. Okay, the closest distance it has to the wall, which is here, is 10 cm from the wall, and the furthest distance to the wall is which is here, and here to here is 30 cm. So we can deduce that from the furthest to the closest, this part here is 20 cm. And the center point is going to be the center point of this 20 cm. So this is 10 cm, 10 cm. So the center point is actually 20 cm from the closest, from the wall. Okay, the closest is 10 cm, the furthest is 30 cm, the center point at the midpoint is 20 cm from the wall. Okay, then we are also told that to travel from the 10 cm distance, that means from here to the 30 cm distance, so it takes from here to here is 4 seconds. But we also know that from here back to here also 4 seconds. So from here to here 4 seconds, back again is 4 seconds. That is one cycle, 8 seconds. Okay, then the question further tells us that it is at the furthest distance from the wall at t equals 0 seconds. That means when it is at the furthest, we start the stopwatch. So t equals 0 is here. Then it takes 4 seconds to reach here. So here is t equals 0. Then reach here is t equals 4 seconds. Then come back to here is t equals 8 seconds. Okay, so with this information, we were able to fill in the blanks of the graph. Okay, taking x to 0. Okay, there's something new here. X. Taking x to be 0 cm on the graph to be at equivalent point. So what they are saying is this point, we'll call it x equals to 0. In fact, x is actually the displacement from the center point. So just now, at the beginning, when it's here, is 30 cm from the wall. This point here is 20 cm from the wall. So when it's here is how far away from the center point? We just we just figured out that this is 10, 10. So at the furthest point, it's actually 10 cm from the center point. In the center point, they call x equal to 0, and here will be x equals to 10. 10 cm being 10 cm from the center point. So at the beginning, when it's here, it's 10, x is 10. Then when it comes to here, x is 0. And when it comes to here, x will be minus 10. Okay, because it's now on the opposite side of the equivalent point. Then when we come back to here, x is 0 again. Then come to here, x is 10 again. Then come back here, 0, minus 10, 0, 10. So that's how the x works. Okay, x is actually the displacement of the object from the equivalent point. Equivalent point is always taken to be 0. So now we have the graph. We're going to fill in the graph. We're going to fill in the blanks. So it starts with x equals to 10. Okay, then it comes to the center point where they say x is 0. Then they go to the other side, x is minus 10. Okay, 10 cm from the center point, but it's on the opposite side of the equivalent point. Then when we come back to the equivalent point again, x is 0 again. Then when you reach the furthest point, x is 10. So let me repeat. So this is 0, this is 10. 10 cm from the center point. So here is 10, 0, minus 10, 0, 10, 0, minus 10. So that's how the x works. Then we also know that from here to here, here's the furthest point, here's the closest point. So from here, from 10 to minus 10, we are told that it takes 4 seconds. So from the closest point to the furthest point, take another 4 seconds. So one period is from here to here, back to here again. Okay, so total time is 8 seconds. That's for one period. Then another cycle, 16.0 seconds. Okay, so that's how we fill the graph for point A. Okay, part B, state the distance of the equivalent point to the wall. That means here is how far to the wall. Okay, I think we have just figured out this is 10, this is 10. So this to this is 20. Okay, so the answer is 20 cm from the wall. Okay, that's part B. Then part C, write down the equation of the motion of the system. Basically, the equation is this graph equation. It's actually a cosine graph. But the amplitude here is 10. So it's going to be 10 cosine graph. But it's not cosine t. We know from simple harmonic motion is cosine omega t. Okay, omega. You have to find out the value of omega. The formula for omega is 2 pi over t. So before you write down the equation is 10 cosine something t. The something is your omega. Omega is actually 2 pi over period. Okay, so we work out the 2 pi over period. That will give you 0.785 radian per second. So now you can go ahead and write down the equation for x, which is 10.0, the amplitude, times cosine omega. Omega is 0.785 t. So this is the equation that they want, the equation of motion of the system. Okay, then part D, show that the mass is 25 cm from the wall at time 1.33 seconds and 6.67 seconds. Okay, this question is a bit strange. Is it that we are given this value and then show that the time, the corresponding time is this and this? Or is it that we are given these two value and then we figure out, and then we work out, we find out at these two time the corresponding distance is 25 cm. Okay. So is it given 25, then we go and find t, or is it we given this t and then go and find at this distance? Okay, we'll do the harder way. We're going to assume that we are given this value 25 cm from the wall, and then we're going to find the time, the two times that it is at 25 cm from the wall. So to do this, we're going to use this equation. We're going to put in the x value, and then we find the two values of time. Okay, but then be careful. This x is the displacement of the object from the center point, the equilibrium point. This 25 cm is not x, because this 25 cm is from the wall. So before you sub into this equation, you have to figure out what is the corresponding x value. Okay, 25 cm is from the wall is somewhere here, because here is 20 cm from wall and here is 35 cm from the wall. 25 cm from wall is here. X is the distance of the object from the center point. Center point is 20 cm from wall, so I think you can figure out that this object here, when it's at 25 cm from wall, it should be 5 cm from the equilibrium point. So when object is 25 cm from wall, actually the x is actually 5 cm. Okay, so that's the first thing that you need to figure out. X is 5 cm. That means it's here. Okay, 5 cm from the equilibrium point. So you're going to sub in 5 into here. That's what we do. We sub in the x5 into here, and then we find the corresponding time. Okay, this is a trigo equation. In math, when you solve a trigo equation, you know that a trigo equation can give you infinite answers. They want the first two answers. So when you're solving trigo equation, how do you get the first two answers? Remember the ASTC thing? For cosine, the first answer is a first quadrant. The second answer for cosine, right, it will be the fourth quadrant. Okay, in fourth quadrant. So what we do is we bring the 10 over to the other side is 0.5. Then we do cosine inverse. But be careful, these are all in pi and radian. So you must use a radian mode. So when you do inverse cosine, you actually get pi over 3. That's your first quadrant. For cosine, the other second answer will be a fourth quadrant. Okay, 2 pi minus pi over 3. Then from there, you can get the two corresponding t value, 1.33 and 6.67 seconds. So that's how you get the two answers. Alternatively, if you don't know about this fourth quadrant answer, you can work out the normal answer first, and then you look at the graph. 1.33 is somewhere here. Then by symmetrical, the second time somewhere here. This is 1.33. Okay, here to here is also 1.33. So what is this T1 thing? It'll be 8 minus 1.33. Okay, so you also get 6.67 seconds. So this is without using the first quadrant, fourth quadrant answer. So you also can take, you can also do it by this way. Okay, so that's the answer for example 2. Okay, the last part is basically just a math question solving a trigo equation. Okay, basically it's just like this graph, find the two times where your x is 5 cm. Okay, sorry, there's a mistake here. It's not minus 5, it should be plus 5. Okay, but actually there are infinite solutions if you go on and on. Just like every trigo equation, there are infinite solutions, but they only want the first two answers. Okay, so that's it for example 2.